Good morning, good afternoon, and good evening, everyone. Thank you for joining Learn Kubernetes with Google on Google Open Source Live. If you haven't attended Learn Kubernetes with Google Live before, it's a series where we explore different topics within the Kubernetes project and its ecosystem. Today, of course, it's all about Dockershim. My name is Bob Killen. I'm an open source program manager here at Google, and I serve the upstream Kubernetes project as a lead for the special interest group contributor experience and as a member of its steering committee. Today, I'm joined by some esteemed panelists from RedHat, Docker, VMware, and of course, Google. Now, a little housekeeping to sort of get out of the way. There is a Q&A forum below where you can ask your questions, and we'll be answering them in the later half of this panel. If you want to share your experiences on Twitter, please use the hashtag #LearnKubernetesWithGoogle. And with that out of the way, let's meet our panelists. Cool. Now, I'm a fan of the sort of hot potato intro game, so I'll call out someone and then please call the next person. And I think I will go for Dims.
Hi, my nickname is Dims. So you can find me on the CNCF Slack or on the Kubernetes Slack. I'm usually trying to do some maintenance work around Kubernetes for sure. So that's my intro. I work for VMware as well. Hot potato to Dawn.
Hey, thanks, Dims. My name is Chen. I work at Google for about 15 years. I'm one of the original engineer for the Kubernetes, even before Kubernetes inception. So I'm currently still run the chair of the SIG-node, Kubernetes SIG-node, and is really looking forward to meet everyone here. Oh, next one I will throw to Mrunal.
Hi everyone, I'm Mrunal Patel. I'm a software engineer at RedHat, working on containers and Kubernetes. I'm a maintainer of runc, the OCI runtime spec, cryo, and I'm also heavily involved in SIG-node. Sergey?
Hello, I'm Sergey Kanzhelev. I'm working on Kubernetes for 2 years. Before I was heavily involved in other open source projects, and I'm mostly participating in SIG-node and heavily involved in Dockershim deprecation and removal. And Justin, you are the last.
I'm the last one, so yes. I'm Justin Cormack. I'm the CTO at Docker, and I'm also on the CNCF Technical Oversight Committee. And yeah, I've been a maintainer on the Docker projects for a long time and been involved in the whole kind of a lot of the things we started around containerd and how these things got together. And it's nice to be with you all today.
Awesome. Thank you for being here. And it's actually perfect to end on you because the first question is for you and Dawn. But please, if anyone else has any other comments, please feel free to jump in. With that, what is Dockershim and why was it created?
Maybe I go first. Dockershim is a built-in module and in Kubernetes, the node agent to communicate with Docker via the Container Runtime Interface, we also call CRI. Why we created of the Dockershim at the first place? Here's a little bit of the history. In the early day of the Kubernetes, the only container runtime was the Docker, but there was some issues like Docker doesn't understand Kubernetes pod concept. The integration, it is arbitrary in the code space all over the place. Incompatibility issue pop up every time when we try to upgrade Docker version. So in 1.3, we introduced Racket as additional option. Both Docker and Racket integration was entangled in the Kubernetes code base all over the place, which made the future maintenance much harder. Also, there are all demands on the supporting more container runtimes from the community. For example, hypercontainer, today's Kata containers. Integrating a new container runtime is a very difficult task because this requires a deep understanding of the Kubernetes internals. To address above issues, we decided to create the standard interface. Container Runtime Interface to define how Kubernetes interacts with different runtimes. Container Runtime Interface work was initiated in the 2015, and in May 2016, Yuji and I published the first API version to the community. Back then, there were many questions and skeptics on the API and the new container runtimes. To validate the interface we created, to ensure of the incremental development, and to reduce the maintenance burden with the velocity before finalizing the interface. So we decided to integrate Docker, the only production-ready container runtime in 2016, as the first container runtime without the CRI. Hence, we created of the Dockershim. Also, meanwhile, use creator of the Dockershim, so Dockershim and Kubernetes are bundled as the one binary. So there are no version school issue from the initial. So in these cases, we can tolerate breaking API changes for the faster iterations. This means that we can switch to using CRI as the default for the in-process Docker integration while the API are still in the alpha. Then we can enable of the other container runtime development parallels. Justin?
Yeah, so I mean, I think I was sorry, I was being distracted by all that history. It's really fascinating. I think that there was a lot of things going on then, and I think that you know, back then is when we created Containerd, and I think that was all for very related reasons. When Kubernetes started, Docker was it was obviously the only container runtime, and it was obviously the obvious and only choice, and they worked together very well. But there were all these different design decisions that Kubernetes made. You mentioned pods, but also like how networking should work and things like that. So that's why we got back together. I think it was in 2015 or 2016 with Google to talk about Containerd and like splitting out. Let's split out the common parts that we're both using, make a really robust, reliable runtime that will support these bits, which was Containerd. And we both build on that in different ways, take the bits we want, make it work nicely with our projects, and let's not be all kind of tied together with tied releases and cross testing and everything, because both projects were moving really fast. It was all, those times were quite chaotic back then, and we were trying to build build platforms that the millions of users that we have of Docker and Kubernetes today could use, but it wasn't there then. It was there was a lot of work to do back then still. It was just a kind of a dream of getting to where we are now. So I think that splitting out the code that talks to Docker meant that it was more isolated. Having the CRI was really helpful because it kind of said, this is what Kubernetes needs to run. This is the kind of interfaces that make sense for Kubernetes. And also potentially evolve CRI. I mean, I think CRI actually needs a bunch of work since the, that's but if it wasn't defined as an API, it was hard to actually do the work because, as Dawn was saying, it was all integrated all over the code, and there wasn't really one place we say, this is the API now, but we need to version this and move and make changes here so we can do new things.
So moving from the wild, wild west of development to something a bit more stable. Now, I've heard CRI tossed around a bit. Mrunal, could you possibly explain a little bit about it and what it's done?
Yeah, absolutely. So think about what are the two major things you need to run a container, right? So when everyone is familiar with the Docker experience, when you do a Docker run Ubuntu shell, what's happening? So Docker is pulling the image from a registry somewhere, the Ubuntu image, bringing it down on your computer. A root file system is created, and then there are some system calls being made, and you see what we call as a container, right? So there are two main parts in the CRI. So one is the image service. The image service is responsible for for management of the images. Like it ensures that, hey, when you specify a container image in your pod, is that image available locally or not? If it's not, it will talk to the container runtime, and the container runtime will pull it down. And then it's also responsible for like removing those images when your disk is running out of space and so on, like the GC of the images. And the other aspect is actually instantiating a container, right? So that is the life cycle of, I need to create a pod sandbox. I need to create containers within that. I need to start them. I need to check their status, because if they go down for some reason, I need to restart them, list them, and so on. So the other part is the runtime service, which is responsible for the runtime aspect of managing pods and containers. So CRI is made up of these two services, and kubelet uses these services, and then folks are free to implement them in whatever way they want to optimize their runtime for. So like Justin talked about how Containerd was designed so it could work well both for Docker and the Kubernetes use cases. So we at Red Hat took a different approach. We thought like with cryo, what if like we have spent time standardizing components in the OCI? How about we make a minimal runtime that is designed just for Kubernetes, right? Kubernetes is the only consumer. And what trade-offs can we make? Like, so the idea is to take all the OCI pieces available and work with OCI runtimes like runc, and crun is another option today. And another decision we took was like, let's keep it simple for users. So cryo versions are the same as Kubernetes versions on the minor release. So it's easy. Hey, you're using Kubernetes 123, you got to use cryo 123 and so on. Some other pieces like, so there were contributions from Red Hat to Docker early on the various graph drivers and so on. So some of that code was kind of reused to satisfy the storage pieces to instantiate root file system for the containers.
Thank you. Now, I heard you mentioned OCI. Justin, since you were involved in Docker, and so the inception of OCI, could you expand on that a little bit?
Yeah, so OCI is short for Open Container Interface. We kind of always call it OCI. It sometimes gets confusing when you read something from Oracle Cloud because they use OCI too, but it's nothing to do with that. So Open Containers is another Linux Foundation organization that we set up with the community because, again, it comes back to what we were talking about before. Like in the beginning, like everything was just defined by how does it work in Docker. Like, what's the definition of a container image? Well, look at the Docker source code, and you can kind of reverse engineer it from there. And over time, there was actually quite a lot of really big changes that happened, like the image format v2, which was changed to be content addressed for really important reasons, security reasons, and it was actually a major improvement and things like that. But it was documented mainly in an issue and some PRs in the repo, and this made it really difficult for people who wanted to build other tools around the ecosystem or make changes and improve things. And once it was not just Docker, and there were other people like Kubernetes and other people experimenting with new things like Rocket, and there was this whole kind of community of people like really excited by containers and wanting to build stuff, and it's like, well, what is this stuff? And so we set up OCI to basically define the stuff, take it out of the Docker issue. I mean, literally the first version of the Git repos was just copying things, pasting them out of the repos and putting what we had. And then like, let's start editing this. Let's make some, better specifications. Let's agree on what the usage is. Let's move runc into there, which was the first bit we spun out of Docker even before Containerd was like the actual runtime, because it had been originally, it was libcontainer. It was a kind of semi-standalone part of Docker, but we split it out into runc. And that was like, here's a runtime. Here's the API for the runtime. That's the runtime spec. And then we took the registry API and the image format API and documented those as well. And we since discovered there's lots of other APIs that are also not documented that still need to be added as well, because there's there's actually lots of pieces and lots of commonality we're using, and we're finding out more and more things as people want to make more and more tools that work across everything. There's more things we need to specify, and kind of OCI is working on that too. But I think it's really, it really helped the ecosystem to kind of spread out into like, let's allow people to just build tools and work out what you can do and invent totally new things and try and specify new things, and also work out like when there was a difference between two tools in how they behaved and it made a difference to users. Like, let's work out which one's right, how we should adapt, what the best way of adapting to the reality of not breaking users is, because lots of things we found out were just there because just this is the way things were. Maybe we shouldn't have designed it like that, but there are millions of clients out there that behave like this, so we can't really just go and break them. So let's document the behaviors that you have to allow for and the kind of edge cases, so that when you're building a new tool, you can read the edge cases and discover what you need to do, and also over time fix things as well and make big changes. I think we've been slower at that, but there's been quite a lot of innovation, but I think there's still more work to do in sort of moving towards sort of larger changes, and because making big changes in the ecosystem is it's just difficult because of compatibility. So there's still I think there's still more work to do, and I think we're starting to get better at that in OCI now. I think we've got this the consolidation thing happened. Containers exploded. We got millions of users, and then it's like, well, okay, what can we change? What do we need to change now? What have we learned? How is the ecosystem different from how it was years ago? What do we need to start changing? So OCI is working on that, and come along and participate.
Is there any like big things on the horizon for OCI, or like currently being planned to like bubble into it?
Well, there's a lot of work around standardizing, what I'm particularly involved in, around image signing and the security pieces, because that was kind of unfortunately a bit of a afterthought and designed afterwards. So there's a lot of work on standardizing that going on at the moment. And there's a lot of people interested in different image formats for different things. I think there's been a lot of proposals and experiments around new image formats, which I'm really excited by. Other things I think have worked quite, Dawn mentioned different runtimes. I think the runtime pluggability has been working amazingly well. There are lots of runtimes now, so that bit's been really, really good. I think lots of people have experimented with new things in runtime.
Actually, on the subject of runtimes, like we've tossed in a couple, Rocket, we have Container D, and the cryo. Can folks expand on some of those a little bit? And I know like what ones are people using in production?
I think that runtime is slightly an overloaded term, but the Kubernetes runtimes, because there's lots of layers of runtime all the way down to runc and kind of up. But yeah, I think that Rocket's been retired, but no one's using that now. But it was an interesting experiment we learned from at the time. But I think we're in production. In production at Docker, we use Container D runtime, and but in Docker Desktop, we ship with Dockershim runtime, and we'll be shifting to the external Dockershim runtime that Mrunal is maintaining shortly to keep the developer experience.
So we've been like OpenShift, which is a distribution of Kubernetes, has been like shipping cryo as the default runtime for nearly 3 years now, with thousands of customers. And so I think that makes me feel that we'll be okay. Like there's quite a lot of users out there.
Maybe I can say the Google, the GKE side. For the GKE, we geared the containerd on the Linux node since June 2019. And then also allows the containerd as the default container runtime on the Linux node since I think the GKE 1.19 release. And also we geared the Windows containerd since GKE 1.21. So I also know some other on-prem vendor. So they create their own. That I think they plug into some different container share and implementation to satisfy their enterprise ready requirements. I also know there are some Kata containers and are supported in OpenStack. I also heard AWS Firecracker support CLI APIs. So there's many things. Maybe Dims also can through some other use here.
Yeah. So most recently, for example, there was a proposal for enclave containers. So this variety of experimentation that is going on. Definitely gvisor comes to mind, Firecracker, Kata, Singularity, Sysbox. So lots of people are trying to do lots of things around it. Some of these need specialized hardware, so you might not find it in a cloud provider, and you might have to roll it in on-prem. But there is a lot of excitement around how can we protect the containers better? Do we need like a thin VM layer around it? So some experiments are going on there. There are experiments around noisy neighbor issues and how to overcome those kinds of things as well. So this is a good time to be in because there is so much innovation happening. And the other part is like everybody is trying to collaborate better. And between the communities where I work, Docker, Containerd, and Kubernetes, there's like lots of cross-pollination, people using each other's code, and like we are trying to move things out into libraries to reduce circular dependencies between the different projects. So I'm happy doing all these things right now. So
Awesome, thank you. It's giving us like a good picture of the ecosystem. And let's go back to Kubernetes for a minute. And for Sergey and Dims, so why is Kubernetes actually removing Dockershim, and why has it been such a pain point?
Let me give a little bit of a preamble before I hand it over to Sergey. So when I started looking at dependencies graphs of things that we render into Kubernetes, we found like lots of cloud providers and credential providers and like Docker, Containerd, Runc. Like we have code from almost everybody. Like what was happening was it was becoming very hard to like upgrade anything because there was like you had to essentially try and see what works together, right? And then the combinatorial explosion was too much. So we started putting down some rules around like, hey, we need to use specific tags. Let's try to remove dependency chains and things like that. And one of the problem areas that came forward was cloud provider was definitely one, and the another one was Docker. If I have to call out, like if you take the VMware vSphere vendored code, that itself is huge, bumping up memory size of kubelet, for example.
So quick thing. You said cloud provider. What does that mean in terms of Kubernetes?
So cloud providers are essentially when Kubernetes started. If you had to run Kubernetes in the cloud and Kubernetes had to talk to the cloud provider to do something specific, then we ended up using the client libraries for that specific cloud vendored into Kubernetes directly. So essentially, how to talk to a load balancer, for example, right? Or talk to the storage. So there's various dependencies that got added over time, and we were finding it really hard to manage these things. So we started figuring out how can we move cloud providers out? How can we move Docker out? How can we move other pieces out so that we can have a slimmer and trimmer Kubernetes, especially when you think about the edge use case and ARM and other areas also. You need something that is stripped down small, right? So the preliminary work that we ended up doing, trying to remove these things, actually helped in another innovation, which is the explosion of small Kubernetes distributions like K0s, K3s, and et al. But anyway, that's a longer story. Coming back to, before I hand it off to Sergey, was essentially like there was an issue around how fast the SIG node could introduce features and changes in kubelet. And we started wondering how we can increase the velocity of the team. So that was the preamble. Sergey, can you please add more context?
Oh yeah, absolutely. And yeah, but I really enjoyed listening to you, so don't worry to pass it to me. Yeah, as you said, the trim version of Kubernetes is amazing. We unlock so many new scenarios, but having something in code has another big disadvantage for community. It's hidden dependencies. Like if something stays in code and builds with Kubernetes itself, and then develop a new feature, you may not notice something the way you took a dependency on specific feature of runtime, and it kind of neglects all the standardization and standardization work we're doing, especially around like this is a clear interface, just implement it and everything works. No, it doesn't work because you have this hidden dependency, and now you need to fix it and adjust for that. So moving Dockershim out of tree really helps with cleaning up these dependencies, and we have this huge diversity of runtimes now. Each runtime is not created just for fun. It's actually attempt to find a new balance and new trade-off between performance, workload isolation, and security. And having this new runtime, you need to be thinking of like how do you implement it, like what you need to implement, and how it will integrate into Kubernetes, so you don't think about all these hidden dependencies and like preferred runtimes. And we switching from push model when we kind of have a feature and push it in Dockershim first, otherwise nothing works. And then we think about other runtimes. We switch to pull model when all the interested runtimes that interested in the feature, interested in implementing specific functionality, they can come and work with us and implement it. That said, we still have a lot of desire to keep most of runtimes aligned on feature and make it simpler for end users to switch between runtimes.
Yeah, let me illustrate this a little bit. For example, what ended up happening was some developer said, hey, I want to do something on the node that I'm running on, right? And they said, okay, let me run things as privileged, connect to the Docker sock, and do whatever I want, right? So things like that is a security risk, and like it breaks the abstractions and so on as well. So that kind of like started us down this path of like, okay, can we split kubelet into two, and the portion that is dependent on Docker, can it run standalone? And we ended up moving that code out of our repository eventually, and it ended up as what Justin pointed to out as an external CRI Docker daemon.
Thank you for
yeah, it has a lot of benefits for end users as well. So end users now have easier time to pick between runtimes. Before it was a little bit more skewed towards Dockershim because it's default, it's always supported first. Now you're not afraid to take dependency, like take new runtime and experiment, and know that it's likely will be supported because all the interfaces and OCI has you covered.
Yeah, and everything you take out of the core just makes development easier in the core. I mean, we've had projects at Docker that had a load of stuff in the core, and they just stagnated eventually because you want to make a change, you have to test it on 30 different things. Like with Kubernetes, like the cloud providers, I want to make a change to Kubernetes across everything. I have to test it on Google and Amazon and VMware. It's like this just becomes really difficult. And so the more you can take out of the core and just have standardized APIs that you can test against mocks and like that kind of thing, it makes it so much quicker to actually just iterate on the project and make really big cross-cutting changes without being scared that you're breaking stuff. And I think optimizing for developer velocity on actually iterating on core features and the nightmare world of Go vendoring is a really huge kind of benefit for developers.
Yeah, I can tell you a quick story about that. So right now, if you go to Kubernetes code base and you look at Go mod, you will see both runc and containerd. You go and cAdvisor. You go to cAdvisor, you will see containerd and Docker. And then you go to containerd, you will see runc and Docker as well. So it's just a painful to move any one of those components. So we are working together, people from Docker and Kubernetes and other even people working on runc and other communities as well. And we are trying to find out how to break these chain of dependencies to make things simpler and development process easier.
Yeah, I think one thing that's come out is like if we can separate out the C groups management library from runc, that'll really clean things up. Hopefully we can get to it soon.
So quick thing, what is C groups?
Okay.
The TLDR version. This can be the entire talk itself.
So when you think of containers, right? In the Linux kernel, there's no such thing as a single API that says create container. So containers is a made-up construct, right? And the features that make up containers are like Linux namespaces, C groups. Those are the major things. So namespaces give you an isolated view of a resource. So when you go in your Ubuntu container and you feel as if you're in an Ubuntu, even if your host is Fedora, that's because of the mount namespace, right? You can't see other PIDs outside of your container. That's because of the PID namespace. So those are namespaces. They give you an isolated view of a particular resource. You get your own network stack and so on. So that's one part of it. The second part is how do you constrain the resources used by a container? That's where C groups come into the picture. So with C groups, you're able to say, oh, okay, for this process, please limit the memory to only 100 MB and give it only so many CPU shares. So that way we can make sure the resource consumption doesn't go beyond those limits, and you can run many of these containers. You can do calculations. Okay, I have so much memory, so I should be able to fit so many of them. And kernel uses C groups to enforce those limits.
Do we even want to talk about V2?
Well, I mean, I think
how much time do we have?
I mean, I think that one of the issues, again, it comes back to history, is that the runtime interface was really originally, it was just kind of quite. I mean, I kind of describe it as a JSON copy of the kernel API, and it kind of does feel like that, which is kind of horrible and really doesn't have a good abstraction over things. And so, the C group stuff was a copy of the kernel API. Kernel introduces, you've got a choice of APIs, V1, V2. It's like they're different. And it's like, well, okay, so we really tied, runc to the original API, and the kind of that we haven't got a mapping in between these. And also doesn't work very well for people doing completely different runtimes that have different kind of ideas about how things should work. Like the Windows API for Windows containers have to be totally different anyway, but there isn't really an abstraction. So I think there's still work to do to untangle some of the kind of, is this just a Linux kernel interface, or is it, because a lot of that stuff trickles right back up to what the user sees, and the user experience for those at the Kubernetes level or Docker level is just really horrible for the user, because it's really hard to understand unless you're a kernel hacker, which is not the idea.
Yeah, we hide a lot of things that you don't want to see.
If next time I have time, I really want to talk about the history when I was working on the board, how we interact with the kernel back then before first the C group published. And so that's a really fun story I want to share with.
That'd be a great KubeCon talk for North America. Can have a panel of the history of containers and Kubernetes and all that.
Yeah, we can talk about how Google Borg and to using before the MCG, like the first current memory container and the C group published, and how we are divided the memory and then interact all those what kind of problem, why we so desperately need a well-defined kernel interface and to help us to move forward. Yeah.
So we've kind of covered a little bit of the history, a little bit about what all this is. Now, we know that Dockershim's removal is going to cause some friction for people. So Sergey, could you expand on what people have seen and what end users are impacted by this?
Yeah, we ran a survey in Kubernetes community among end users, asking whether they feel prepared for migration. And surprisingly, we have even though we made an announcement before and we talked about it before, many people cited that lack of documentation and lack of understanding what needs to happen was a problem. So we trying to address it before 1.24 release. We have dedicated team working. It's community team working on documenting all the issues and migration steps. I participated in many migrations inside among Google customers, and I know that many big and small customers migrated just fine without any issues. Majority of questions was what to do with my third-party monitoring and security agent, and in many cases the answer was just use a new version or just follow the guide to update small configurations there, and you will be covered. So at least this is good. And then for some customers, it was a little bit more involved because they needed to change the way how they configure image pooling. Some customers configure mirrors on their registries or some proxies, and they needed to mess around with Docker configuration before, and with switch to Containerd, they needed to change Containerd configuration. It's a little bit different format, but it's all well explanatory and very straightforward. And lastly, I think, among issues, we end up finding some incompatibilities between Docker and Containerd. It's a rare cases. One issue I remember is non-OCI compliant image that's still supported by Docker for backcompat. It's not supported by Containerd because it's not OCI compliant. So we end up suggesting some workaround, and a very old image was replaced with a little bit newer one, and it worked like a charm. We had a couple more issues like that, and but in general, it's all covered, and most of the customers migrated with no problems. The only problem is how you schedule time around migration and how you do plan it in your busy schedule. Yeah.
So if there's a checklist of little bullet point items, what would you say people should look at to make sure that things are good, that they're prepared for migration?
Yeah, on Kubernetes side, we listed all the possible dependencies, all the dependencies we saw, and you can just follow this list and find all the daemon sets that may have taken dependency on Docker socket. You may find check whether you configured the registry, and some couple more items. But we saw one occurrence when one customer took a dependency on log format from Container Runtime. And funny thing was that it was JSON versus non-JSON. It ended up that two runtimes has exactly the same log line, except the one is formatted as a JSON and another is not in JSON. It shows how close these runtimes are. So they end up just changing their filter of logs a little bit, and it just worked. So yeah. Nice.
So honestly, while there might be some friction, it doesn't sound like it'd be that bad. Everything should still work. So with its removal, this is sort of a question for everyone. And we've touched on some of this a little bit already, but so what does its removal sort of like enable or unblock for the future of Kubernetes? And is there anything that like you are particularly passionate about that its removal might open the door for?
I can talk about one. Like in general, I think we said like decoupling makes it easier to like add things, and then runtimes can go at their own pace to implement that. So along that line, like user namespaces is something that has been open for a long time, and a lot of work has been done in the kernel side. And I think finally we are at a stage where we merge the phase one KEP for it. So I'm very excited that hopefully we'll see that feature come in 125.
What is a KEP?
KEP is a Kubernetes enhancement proposal. So if you want to add a new feature to Kubernetes, you have to make a proposal, basically create this enhancement, and then work with the SIGs, like SIG nodes or whatever SIGs are relevant, and get that enhancement approved and merged before any of the code can be merged into Kubernetes. So it's a whole process which is working pretty well to make sure that we are deliberate about what features we are working on and how we are prioritizing them.
I am very happy about like the developer velocity. So just to give you an idea, the PR that where I removed the entry Dockershim ran to like 53K lines of code, right? Like, so that's gone. I'm more happy taking out code than adding code. So and the Go vendor dependencies became far more simpler. I think it helps in two ways. It's not just the updating the dependency part, but it is also like when somebody is working on certain things, like right now people were working on how do you increase the CPU that's allowed for a same container or something like that, vertical scaling, right? So things like that becomes easier because they don't have to worry about a bunch of things to land and tested. Because they can separate that out to say, hey, this is going to be taken care by the container shim or something else down the line. So let me just concentrate on like the API contracts and get the code in, put in some mocks, and then add the test cases, and then go update the different runtime implementations and things like that. So it becomes simpler for people to get something new working in the community.
Sorry, go on.
Maybe I just want a different angle to share this one. Velocity things, development velocity. Both Mrunal and Dims came from the open source perspective. But one of the reason we also have this container runtime interface as today, it is we want to unlock any of container runtime. So not just help like the the community, right? So to develop different runtimes, satisfy different users' requirement. Also, we kind of try to empower and the vendor itself and can to satisfy their own customer. And I just want to using Google as example, like GKE development, GKE sandbox feature, and also the GKE image streaming features. They are only available on the node with the containerd, sorry. And so we could make that happen also through the Docker, right? So, but it is feasible, but it is way more work and will slow down all those velocity, all those kind of things. So this is why we're choosing containerd, because it's well-defined self-contained and with the defined API. So that's why we are doing those work there.
Yeah. I mean, I think I'm looking forward to taking out more things now, because I think this has actually taken a really, really long time. Dims has done a lot of work on this. It's been talked about for years. Taking out the cloud providers has been talked about for years and still hasn't. Like, I think we're showing users that we can move things out of core, nothing breaks, you can still run them separately. It's not the end of the world. We know that lots of users were stressed about this, which is why we're having this panel, and there's been these conversations, and I'm doing blog posts and things for it, but it's like, it's not the end of the world. Nothing's really breaking. It's just it's a development model that we know makes sense, going to make things better, and let's get out some more stuff 50,000 lines of code removed is not enough. There's hundreds of thousands more to go. The vendoring and things they're real problems across the ecosystem for people building tools that use Kubernetes to do other things, and that and experimenting with new use cases for Kubernetes and things like that. And it's like there's more work to do, and it's good that we've done the first one, because there's plenty more work to do still.
I think the goal of once a project has reached maturity, so the goal is then to remove code.
Yeah, exactly.
Okay. One last question before we move on to the Q&A. What is something that users might not actually be thinking about, but should, when they migrate from Dockershim?
I can take one example, like builds, right? Like a lot of people depend upon Docker to do their builds. So they should check if they have a dependency on Docker daemon running for their builds in some form. And they should look into alternatives like Canico, build kit, and maybe use something like Tekton on top of it to simplify the whole thing. And,
yeah, I mean, we again, like it's part of the history. We modularized build kit out of Docker so that you could run it in other places like Kubernetes, and these things are all not designed to be big monolithic things that you kind of depend on how one thing's set up to run another thing. It should all be independent, and so yeah, completely. Just build kit is just the Docker build pieces separated out, and you can use it separately or with Docker, it's all the same.
Yeah. And maybe you want to, I all agree. Build, maybe you want to take care first, and but it's being taken care of by community and the vendor here. But there's another things from the end users. I want to mention that the local debuggability changes, and so a lot of people end user get used to the Docker PS and all those kind of local debugging mechanism. So you cannot using those like the Docker PS and the Docker logs. But instead, actually, when we create off the Dockershim and the CLI, we also create off the CLI kubectl to achieve the same functionality. Even better, actually, since the CLI kubectl tools is built on top of the CLI interface. So the tool itself understands the Kubernetes concepts, including of the pods, the namespace, all those kind of things. Yeah.
So taking off my Kubernetes hat and putting on my Containerd hat, I would say try it out and come to the Containerd channels on CNCF Slack and ask for help. We'll point you to documentation from the Containerd point of view as well. So there is a bunch of things already available on the Kubernetes side of things, but there is other things that we can do on the Containerd side of things. The earlier you come to us with your problems, the quicker it will be for us to try to take a stab at fixing them or giving you a workaround.
I'll say the same thing for cryo. Like, we have a channel, and happy to help.
Awesome, thank you. I think with that, let's move on to a few questions from the audience. We only have about 10 minutes or so left. The first one, Mario asks, is it known if commercial managed Kubernetes offerings will move in a different direction than Kubernetes OSS and continue providing Docker tooling, but with Containerd cryo runtimes rather than Dockershim? So I think it's like Docker PS and that sort of thing.
So the way I read this as, will Docker still be available as on the node, right? So if you think about it, so Justin was mentioning about the external CRI Dockerd daemon, right? So I would expect a managed Kubernetes offering, if they wanted to do Docker, then they would use that, and it's basically the code from Dockershim that was extracted out and is running as a separate binary.
Yeah, I don't think anyone's going to try and provide the sort of Docker interface over something that isn't Dockershim, because I think it would be just too complicated to do. Yeah. I think that would be just difficult, and I think that just it helps to, you're going to have to learn the Kubernetes native tooling eventually to be able to debug all the issues anyway. So it's difficult.
Okay. Well, thank you. Let's go on to the next one. Ramesh asks, will Dockershim removal improve performance, or is it just a cleaning of code?
I can take it up to some extent. So like, I think it can definitely help with performance, like at least on the cryo side, since we tied ourselves closer to Kubernetes and we didn't have any other consumers, we were able to make some assumptions about how Kubernetes invokes cryo CRI calls and make some optimizations, right? So when we compare directly with Docker, yes, it performs better. And I'm sure like Debs can talk to Containerd.
So just the CPU memory usage of the kubelet itself, you will see a really good bump, in a good way, for sure. Yeah, there are other things that will come down the pike in Signode where we specifically look at what performance changes we could make or rewrite. Some of these things were when we were writing, we wrote it because that's how we ended up talking to Docker. Now we don't have that restriction anymore, and there are some things that we could do better going forward.
I can pick up something in the earlier Containerd development 1.1, 1.2. We did the benchmark. Not just CPU and memory, and it's way more efficient. I think if I roughly remember the data I saw, it is the memory usage actually, working sets at least, and it is 60% compared to the Docker back then. And not just that, they also have the scalability, concurrent start of the new container, create of the new container. Actually, the container is back then, it is way better. I want to throw it back to the Sergey. I think Sergey maybe have the latest data after years improve, optimize Containerd. We should achieve even better. Yeah.
Yeah, as you said, there are some optimizations, and but in reality, we're talking about very small overheads that Docker introduced, going to even smaller overheads that we have with Containerd. So realistically, what we saw on end users is performance gains are typically seen on very edge cases. Like if you schedule so many containers right alongside and the same time, then you see performance gain with Containerd comparing to Docker because of some overhead was eliminated. When you have very different kind of aspects of it, you need to schedule many containers, you need to use more CPU, like you running on full capacity of your node, then also you gain a little bit with Containerd, but all that is used edge cases if you just average a Kubernetes user and you don't push limits too hard, then you wouldn't probably notice anything. But I mean, it's a good thing. It allows you to switch between runtimes.
I would also want to add it because the Docker today using the same Containerd, right? So when we optimize Containerd, actually we also optimize the Docker. So it's the same. So I just want to make sure people don't confuse something. Like actually we deliver, even today we deliver after Docker, like out of the Linux box, you may already have the Docker installed, but you could configure that Docker to repurpose that to using Containerd layer and below. And so you still have the Docker there, but then you can plug into that node using the CLI Containerd directly. So I just want to make sure this is mentioned here.
Cool. Thank you. Let's go on to the next question. I apologize if I don't get this name correctly. Regavendors asks, can one or more runtimes coexist for operation and migration at the same time?
So if you're talking specifically about the CRI runtime, the answer is no. Because kubelet can be configured to talk to only one CRI runtime socket, like Containerd socket or the cryo socket. But remember we talked about different layers of runtimes. So under your CRI, cryo or Containerd, you can have runc or kata or gvisor, and they can be configured using a concept called as runtime classes in Kubernetes. So you can have some workloads that are more dangerous and you want to restrict them, you can run them under kata. So I guess like maybe that answers the question. If you want to like give different security profiles and have different trade-offs between performance and security, you can look into
Mrunal, also just for migration purposes, right? You can still run an older kubelet with Dockershim, until
Right.
you are able to get a workload off, right?
Right.
There are some other strategies that are available to migrate as well.
Also, yeah, again, like that, when you talk about different runtime at a different level,
Yeah.
and right, so for a given cluster, you could have the different runtime. So that we have the runtime class. So operator, your admin can configure your cluster, and then you can decide, even using the node selector, you could configure and to have the different container runtime and on a different node, and then serve the purpose you want to have the single cluster, but the different type of the workload, right? So that's
Okay, thank you. Let's go on to the next question. Ramesh asks, do we have a stable version after Dockershim's removal?
I don't really understand this question,
Yeah.
but yes, 124 Kubernetes will not have Docker, and the community will support the previous versions, until they expire, right? Currently, we say that after a version is released, it will be supported by the community for 1 year. So you still have the older versions of Kubernetes that you can still use.
Sergey, did you have a comment?
Yeah, what Jim said, it's pretty straightforward.
Okay. Going to the next question. Vivek asks, do we need to run kubectl DDS and check all the Docker sockets? So DDS, I believe, was a tool recently released by Justin Garrison that just scans things for docker.sock.
Mm-hmm. Yeah, it's a kubectl plugin, and DDS will help you see if any of your workloads are using the Docker sock, and it'll tell you, it'll warn you to figure out how to get rid of that dependency from your environment.
I mean, yeah, as a Docker person, I advise you not to use the Docker socket for this purpose. It does give you full escalated privileges for that container, even if it doesn't appear to from the Kubernetes definition. So it's a kind of dangerous backdoor from the security point of view. Yeah. And it's I mean, privileged containers were another kind of thing. They're not really containers, so be careful if you're using that. Your security team might like to run kubectl DDS anyway, even if you're continuing to use the Dockershim, because they might be interested in what could go on and what someone could do if they got access to that container through some vulnerability.
Sorry, Sergey, go for it.
Yeah, one gotcha in scanning for Dockershim socket is some monitoring agents tries to simplify end users' life, and they mount to all sockets they know, and just use whatever being mounted. So your tool may discover these dependencies even though you don't use them. So you need to, if you want to eliminate them truly, you need to talk to your monitoring agent vendor and make sure it doesn't mount when it doesn't need to.
One other note that might be useful for folk with DDS is that it actually has a mode where it can plug into your CI system. So that way, run it as a check and make sure someone's not, adding a PR that's adding it back to the cluster. And I think with that, we're actually through all our questions. So I just want to say thank you for, everyone coming on and having this talk. I know it's been it'll be useful and hopefully take some of the scariness out of the Dockershim's removal with the 124 release. And we'll call it that as a wrap. And
thanks a lot for hosting this, Bob.
Oh yeah, no problem. Yep. So thank you again for joining us today. please be sure to save the date for our next Learn Kubernetes with Google event on June 15th, bringing high-performance computing to Kubernetes. This is a subject that's sort of near and dear to my heart as a former person that used to deal with HPC. The last thing, please, if you can, take our event survey. It should be on the right side of your screen. That really helps us and informs us how these sessions are working out for you. And with that, thanks again and have a great day.